Select the major product of the following reaction. Our starting material in this reaction is an alkyl halide. The reactions that we have seen of alkyl halides so far have been substitution and elimination reactions. So we need to take a look at this alkyl halide, take a look at the reagents, and decide what reaction pathway is being followed. When we're trying to decide this, the first and most important thing that you need to look at is the structure of that alkyl halide. You need to determine how it's substituted. So we see that the carbon that bears the chlorine has bonds to two other carbons. So we have a secondary alkyl halide. The reactions that secondary alkyl halides undergo are the bimolecular pathways, the concerted mechanisms. So either Sn2 or E2. To decide between these two pathways, the next thing we're going to do is look and see what we are reacting it with. What is our base/nucleophile? And so if we look at these reaction conditions that we're given, we need to decide what we have. So we have sodium cyanide. Whenever you see an alkali metal as a counterion, you know that that exists as a +1 ion, which means that whatever it's attached to has a negative charge. So this is the cyanide anion. That anion is your nucleophile. So we have as a nucleophile Cn-. Okay. With this information, we can determine the reaction pathway. The acetone here, I'm going to mention it, but this is not what determines the reaction pathway. This is the solvant. And this is a polar aprotic solvent. So this will enhance the reaction rate, but it's not what determines the pathway. What determines the pathway is the alkyl halide and what you're reacting it with. And so with a secondary alkyl halide, if you had a strong base, you would see an E2 reaction. The cyanide ion is not a strong base, but it is a very good nucleophile. And examples of good nucleophiles you can find in table 9.1 of your textbook. Okay, so since we have a secondary alkyl halide and a good nucleophile, but not a strong base, we are looking at the Sn2 pathway. And so I'm going to just draw the mechanism for this Sn2 reaction. So we have our cyanide anion, and it is the carbon that is the nucleophilic site here. So the carbon atom of the cyanide is going to approach from the opposite side of where the leaving group is, and it is going to push off that leaving group. Since it is approaching from the opposite side, that means that it'll be facing in the opposite direction. The chlorine was going into the plane of the page. The new bond to this carbon atom will be sticking out of the plane of the page. And so when we draw this, we want to make sure that our new bond is to the carbon atom. So we put the carbon atom there, and then we have the triple bond to nitrogen, which means that we are looking at option C.